Hi, once again, everyone. Welcome back to our statistics class notes here in section 8.3. We are in the middle of page 132, and we'll go ahead and look at here at example 155. So students seem completely attached to social media. I decided to run a hypothesis test for the claim that the majority of all college students visit their Facebook account daily based on a class survey. The results of the test were as follows. Let's explain the p-value in the context of this exercise and state the conclusion. So I just want to make sure, try to drive home the idea of a p-value and how we make conclusions based on concluding a hypothesis test. So the null is that p is equal to 0.5. Remember, that's always an equal sign. Technically, it's 0.5 or less because we want to show alternatively that p is greater than 0.5. Okay, p is greater than 0.5. In other words, I'm trying to test for majority. I believe that majority of all college students visit their Facebook account daily. Okay, so this is what I ended up getting. I had 41 out of 75 who said that they did visit Facebook daily, which gave a sample proportion of 0.55, 55%. Standard error 0.058 here, with a z-score of 0.81. So that's not a very big z-score, not very far away from the assumption of the middle of 0.5. Okay, so a p-value is pretty big. P-value is certainly not going to be less than any reasonably chosen alpha of like 0.05 or 0.10 or 0.01. So we do not have enough evidence to reject the null. Okay, so there is not enough evidence to support an alternative, which is I was hoping to show that a majority visit Facebook daily. So what does the p-value mean? So that means there's a 20.95% chance of getting a sample of 75 students like we have, where more than this percentage, the sample proportion, 54.67% of the students, visit their Facebook account daily if the true percentage of all students is actually 50%, technically, or less. Okay, so in other words, that's the chance of getting your test statistic or one more extreme. That's what a p-value is. Okay, so now, would you reject or fail to reject? Assuming the common alpha of 0.05, right, that's our common level of significance, we do not reject the null since the p-value is greater than alpha. So since we could not reject the null, there is insufficient evidence. In other words, not enough evidence to conclude the majority of all college students visit their Facebook account daily. There's not enough evidence to support the alternative. That's what we were trying to show. Okay, let's do one last example here. Are public libraries in the U.S. a thing of the past? A Pew poll in 2015 estimated that only 44% of Americans had visited a public library in the previous 12 months. Suppose you're doing a project in which you want to determine if the proportion of Americans who have visited a library in the past 12 months has declined from this parameter. So we're assuming our proportion who have visited the library in our population is 0.44 or 44%. Let's say we give a survey to 100 randomly sampled St. Augustine Reds, and we find that 42% of those in our sample say they have attended a public library in the past 12 months. So what I'm interested to find out is that 42% of our sample enough below the 44%, which we're going to have to assume is the truth? Is that enough below that to say that we can reject 44% and the actual amount of people who visit the library, proportion of people who visit the library is less than that 44%? Okay, so we decided to use a level of significance alpha of 5% and carry a hypothesis test. And based on this, you claim that you have proven there has been no decline in library attendance. Okay, have proven. Bad word in statistics. I want you to remember that. We don't prove anything in statistics. We show with a certain likelihood, right? We demonstrate with a certain likelihood, a certain level of confidence, a certain percent chance that we're correct, which are high, but we're not proving anything, which would be like 100%. Okay, so what did we get here? We got a z-score of negative 0.4, not very far away from the assumed middle of 0.44. So our 42% in our sample is not very far away from that 44%. Not far enough away to reject that 44%, that's for sure. Huge p-value, 0.3435. So never use the word proven. Since the p-value is greater than alpha, we say instead that you have failed to reject the null hypothesis. Thus, there is insufficient statistical evidence, not enough statistical evidence, to support the alternative claim of a decline in library attendance.